Okay, taking a look at this big old fraction, trying to integrate it, I know that it looks very similar to that previous problem that you just saw. However, we can't actually use u-substitution on this one. All right, I think typically we would probably try to pick x squared plus 1 to be our u. So let's kind of play it out. Let's say, what if u was x squared plus 1? The next step is you're going to take the derivative of both sides, so you get a du equals 2x dx. Well, I don't have a place to replace in for 2x dx, or even x dx if I wanted to rearrange and get the 2 on the other side. So I can't really use substitution method. All right, now you may be saying, well, that didn't work. You want to use the denominator, right? Well, what if you use 9x was our denominator? As you take the derivative here, you get 9 dx. You're not going to be able to replace the entire numerator, the x squared plus 1. So we actually don't want to use u-substitution on this one. Instead, let's go back to what we know about simplifying down fractions. All right, one technique we've seen already this semester is because you're dividing by a monomial, a single term, you're allowed to take that monomial and split it up to each term in the numerator. All right, so make two individual little fractions instead of one big fraction. All right, this will reduce down a little bit. That works out to be x over 9, or a little bit nicer way to write that in case is 1/9 x to the first power. That x is still up in the numerator, plus 1/9 times 1 over x dx. And all of this is still in the integrand. All right, now thinking about how are you going to integrate this, we'll do it one term at a time. All right, so we'll bring along the 1/9. And then the antiderivative of x is going to be x. It was raised to the first power. We're going to use the power rule, increase it by 1, and multiply by that new exponent. 1 over that new exponent. Plus, the 1/9 comes along from that second term. The antiderivative of 1 over x is kind of a special case. This is going to work out to be a natural log of the absolute value of x. And then for good measure, we always include a plus c at the end for these indefinite integrals. So to finish this up, let's clean it up just a little bit. We can say 1/9 times 1/2 is 1/18 x squared plus 1/9 natural log of the absolute value of x plus c. So I hope this helps out. Remember, if you're dividing by a monomial, a single term in that denominator, you're allowed to split it up and kind of use what you've done with reducing down fractions instead of always using u-substitution.